So the other
So the
Jared,
other Jared,
right?
right?
Sorry, I lost you there.
Lost you there.
Um,
Um,
Jared, he's not
Jared,
gonna
he's
make.
not going to make.
Oh, I didn't hear.
Oh,
I
I didn't
didn't
hear. I
see that.
didn't. Yeah.
Oh yeah, I think
Oh
he's
yeah, I think he's
message.
message.
Oh man,
Oh
I'm
man,
hearing
I'm here
really bad.
for that.
Yeah, me too.
Me too.
Oh,
Hey, how you doing?
hey.
C-score was one. One.
I'm getting some
Get some
feedback.
feedback. I'm Ryan. Trying to do that.
Can everybody hear me now?
Yeah.
Good.
Yeah, that's better. Whatever happened, help things.
Yeah.
Is it repeating now?
I
No.
don't hear it.
No, we're okay now.
And then, so the score was negative 1.75, and then the rest is greater than. 95.9.
Well, looks like everybody's here.
Okay. All right. Yeah. Okay. You guys want to get started?
Sure. Does somebody have the probability
Are you
applet up?
recording?
Yeah, I'm recording.
Yeah, I got it.
Okay, cool.
You want me to just start sharing the screen now, or
Yeah,
maybe
probably.
you'll have to see my ugly face?
Yeah, that way we can. Okay.
Much prettier than my face.
Yeah, that's exactly what I was thinking. All right, so part one. First of all, does anybody have any questions before we start?
Nope.
Okay. So part one, answer number one is what two conditions must be satisfied in order for a sample mean to be normally distributed? So condition one must mean that the well, if the parent population is normally distributed, then the sample mean is automatically normally distributed. And then the second condition is the sample size is large.
Yep.
Then the sample mean is normally distributed.
Gotcha. Yeah.
What is the z-score formula for a sample mean that is normally distributed? Z-score equals x minus the mean divided by the standard deviation divided by the square root of the sample size.
Cool.
I can do three. Suppose a normally distributed population has a mean and a population's standard deviation. What is the probability? What is the probability the outcome is between 5 and 15? So around 68%. What is the 40th percentile for this population? 10 to 5. Or sorry, 10 minus 5 equals 8.7. What is the z-score for an observation of 18.5? That'd be 1.7. What is the probability that an observation is greater than 12? Z-score is 0.4, and so the probability is 0.3446. What's the probability that an observation is less than 8 or greater than 12? Z-score being less than 8 would be negative 0.4. Probability of that is 0.3446 again. Z-score being greater than 12 is 0.4. the probability is the same. So both of those probabilities together would be 0.6892.
Yep.
Okay. All right, so part 2.
I'll take.
Okay.
I can read that. Okay. You'll see. Okay. Suppose pair computing sold an average of mean equals 45 P phones per minute in 2011. Yes, that means they sold 23,652,000 phones. Okay, it was with a standard deviation of 10, and they looked at their P phone sales data and determined that they were normally distributed. So, samples of size 4 are taken from the normally distributed 2011 sales data. What happened? What is the shape of the distribution of X? It's going to be normal because the parent function is normal, or the parent distribution is normal.
Right. Okay. Let's see. Is everybody gone?
I could read them.
Okay, cool. Thanks.
We're on 5, right?
Yes.
Okay. Samples of size n equals 40 are taken from the normally distributed 2011 sales data. What is the shape of the distribution of bar x? And that would be normal.
Yep.
Okay. Let's see. I'll do 6. A sample size of n equals 4 is taken from the normally distributed 2011 sales data. What is the probability that the observed x is less than 40? So we want to
your sample size is 4.
Yep.
And then the value is 40.
The standard.
A z-score of -1. And then we go -1. And we want to know if it's less than. And we get this guy right here.
0.587.
So the sample size is 4. Okay.
So everyone good with that? Or do you guys want to break it down so we know how that was done?
Yeah, let's maybe, can we go step by step on that for just a minute?
Yeah.
Yeah. So the sample size is 4, and I already plugged in these values.
Okay.
The standard deviation is 10, and the mean is 45. And they want to know what the probability is that it'll be less than 40.
Right.
So the equation says to get the z-score, you take this x value, subtract it from this mean, and divide it by your new standard deviation over here, which is just this divided by the square root of this.
Of that. Yep.
So 10 divided by the square root of 4 is 5. So you'd say 40 minus 45, which is -5, divided by 5, which is -1.
Okay.
And then I went into the output,
And
I plugged in -1, make sure this area is highlighted, and I got that number.
Got it. Cool.
And I don't know if I was using the right formula or not. I think I was. But if I wanted to do this on paper, it is. I know this is backwards, but it is that one there, right? It's the z-score equals value minus mean over the standard deviation. That is the right one?
Yeah.
Okay.
And then once you have the z-score, then you have to plug it into the applet.
Oh, okay, so you have to use that anyway.
Yeah, you have to use the applet. You don't necessarily need to use the fancy spreadsheet that Jared made, which is awesome, by the way.
Yeah, it is.
Yeah, that just gives you the z-score, which tells you how many standard deviations away it is from the mean.
Right.
So then you plug it into the applet, highlight the area, which means I want to know
The
this
probability.
probability. Yeah, that it'll be less than the z-score value.
Okay.
The other way that it said that, I mean, the answer key says you can solve it as well, is that you get a standard deviation of 1 or -1, and if you calculate out one standard deviation using like the 65, 95, 99 rule, you're going to get the 95, is it?
65 or 68. I mean.
Yeah, it'd be.
And then you take 68 minus 100, and you get your
30 something.
32. Then you divide your 32 in half because you're only taking the distribution like a big curve, and you're only taking half of that.
You're doing the bottom section. Okay.
Bottom half of that.
Okay. So that works pretty well if you have round numbers.
Yeah.
Yeah. See, this area is the 68, and then the rest is just what's left over from the 100%.
Right.
You get the 2, you get that.
So it's, what is that, 16% on both sides?
So if you click both of them, click down, if you click that, that would be like the whole, that's everything but the 68%. So that would be 168. And then you take only the back half, so you divide it by 2. You're done with that. And now you only have half of it.
Yeah.
Okay. That makes sense.
I mean, that's just another way to solve it. It's not calculating it or anything. It's just a primitive way of doing it.
Cool. Thanks, Austin. All right. Let's see. 7. Who wants to do 7?
I can do it. Sample of size from the normally distributed 2011 sales data. What is the probability that the observed is greater than 35 and less than 55?
So you can either plug in the math or do the 3-number thing that we just did.
Okay.
Let's say that so you see it's 35 and 55. Our mean is 45.
Mm-hmm.
So we want to know between 35 and 55. If you notice, it goes in like even intervals, and our new standard deviation is 5. That we took the standard deviation divided by the square root of the sample size and got the new one, right?
Right.
So 2 standard deviations of this new one down would be 35, and 2 up would be 55. So if we go by that rule, then the probability of that it'll be between these 2 numbers is 95%.
Okay. Gotcha.
Cool. Eight.
Good.
Okay, I can do the next one. 8?
Yeah.
Okay. A sample size of 25 is taken from the normal distributed 2011 sales data. What is the probability that X is greater than 41 and less than 49? So, same kind of deal. You do the equation, you'll end up getting a standard deviation of 2. And you can plug that into the applet and highlight in between, or highlight just the middle because it's going to come out to be 41 and 49, and you get 0.9. It's 95% essentially.
Okay. So that's essentially you calculate that the same way as we did the previous one. It's 2 standard deviations away.
Yeah.
Right?
Yeah. The only difference is that you change up your n, and then you change your mean values, or not your mean values, your sample values to be greater than 41.
Right.
40.
Okay.
But either one you do, it's going to come out to -2 or 2. So we only have to actually solve one of them.
Right.
Gotcha.
Otherwise, it's not a normally distributed property thing, or not normal
Right.
intervals or whatever.
Okay.
A sample size of 25 is taken, and then they want to know the probability that it's greater than 50.
Okay.
So sample size of 20, x value of 50. So just quick math here. A z-score is 2.5.
Mm-hmm.
So go ahead, plug in 2.5, and highlight the right areas. And this is the probability that it'll be greater than 50. So 0.0062.
Yep. Okay. Who's next?
I can read the next one.
Okay. Thanks, Austin.
Pair computing sold an average of mu equals 40 p phones per minute in 2010 with a standard deviation of 12, and they looked at their p phone sales data and determined that the distribution is right skewed. 10 says samples of size n equals 4 are taken from the right skewed 2010 p phone sales data. What is the shape of the distribution of Rx? And that is right skewed.
Yep.
And that can be determined because the sample size is below 30, it's really small, and so it's going to match the same as the parent distribution.
Right.
You can also calculate it out if you use that one output in your website.
Okay. Number 11. Samples of size n equals 40 are taken from the right skewed 2010 p-phone sales data. What is the shape of the distribution of x? That's going to be normal, or approximately normal.
Yeah.
Because it's right skewed, but the sample size is large, so that moves back to approximately normal.
Yep.
Yeah. Is there a theorem that justifies your answer to question 11? The name of the theorem, the central limit theorem. That's the only one there is, right? That we just learned.
Yeah.
Mhm.
Yeah, it's
That one in the theory of large numbers, but
Yeah, that's right. That's the other one.
but you're right.
Yeah.
It's the central limit.
sample size and 4 is taken from the right skewed, and they want to know the probability of less than 35. Can you compute this probability using the normal probability applet with the information you have? Why? The answer is no. You have a right skewed parent data, which means you have to have at least 30 sample size in order to get a normal distribution to calculate this.
Cool. Somebody want to take the next one, or is that me?
Whoever goes first.
I'm first. A sample of size n equals 36 is taken from the right skewed 2010 p-phone sales data. What is the probability that the observed x value is greater than 36.5? So we have a sample size of 36. And where's our standard deviation?
the mean is 40 and the
Is
standard of 12. Alright, so quick math, our new standard deviation is 2. Z-score of negative 1.75.
Okay. That's what I'm missing, 36.5.
I want to know the probability if that's less than that, right?
It's actually greater than.
Oh, I'll highlight the other areas. And get 95.99%.
Yep.
All right. The sample size is now 36. What is the probability that'll be between 37.5 and 42.5? Let's see. 37.5 and what was the other one? 42.5 and 42.5. Right, so they both have the same Z-score values, just opposite, negative and positive. Did you guys see that?
Yeah.
Okay. So it's Z-score is 1.25, and all you do is start at the middle and get, say, 8.87%. Or 0.787. Yep.
Okay.
Cool.
You guys ready?
Yep.
Quiz.
Oh, sorry, I'm a little slow.
No worries.
Me too.
Who's the applet? What is the score of 1.35?
Okay.
1.25. Oh,
We ready to go?
I'm ready.
Okay, so you guys ready?
yeah.
Okay. Number 3 is use the normal probability applet to find the combined area under the standard normal curve that is to the right of 1.358 and to the left of negative 1.38. Round your answer to 3 decimal places.
You guys see this?
1.75.
Yep.
I'm sorry, 0.175.
Do that.
Okay.
Number 4, the United States Coast Guard assumes the mean weight of passengers in commercial boats is 185 pounds. The previous value was lower, but was raised after a tragic boating accident. The standard deviation of passengers' weights is 26.7 pounds. The weight of a random sample of 48 commercial boat passengers were recorded. The sample mean was determined to be at 177.6 pounds. Find the probability that a random sample of passengers will have a weight that is as extreme or more extreme, either above or below the mean that was observed in the sample. For your answers, here it is.
Huh?
So it's asking for the the far left and the far right, the outliers in the data. So like what's the chance of the mean being like that? So what I think you're gonna have to do,
Well, it says the mean was 185, and then the sample mean was determined to be 177.6.
mean used to be 135, we changed it.
Okay, so the mean is 177.6, and the standard is still 26.7.
26 point.
Yeah.
And then
And
you
the
probably can use that as your
the sample was 48 passengers. So that's the
find the
number.
probability that all passengers will have the weight that is in extreme or more extreme.
We gotta find the z-score for this,
Oh,
and then just pick the outliers for it.
isn't extreme greater than 2 z-score?
Yeah.
So do we say, or do we plug in a z-score of 2 or like 2.1? 2, right?
Well, we have to find the z-score for this, so we'll find the z-score and
Oh, like we use the z-score to do it, right? We use the z-score to do it, right? What's the sample size?
Sample size is 48.
So the x value is I'll just do this.
Yeah, I think you can.
I think that's all we do is just plug in the z-score of 2 and then find out what's greater, the probability that it'll be greater than and less than.
Yeah.
As
So this is the
extreme.
probability, right?
So you're assuming that a standard deviation above 2 is going to be extreme, right?
Well, in the rules, it said anything above 2 standard deviations away from the mean or below
Right.
2 standard deviations from the mean is extreme. So
Okay.
it would be a 0.046.
Can you run through that one more time? So you
Yeah. So we don't need to plug in any of these numbers because we know that no matter what z-score or no matter what comes out, the z-score is going to be 2, right?
right.
The standard deviation or the mean is right in the middle, and we want to know, like 1 standard deviation away, 2 standard deviations away.
Yeah.
And then whatever is greater than 2 standard deviations away is extreme. And
Okay.
same with less than 2 standard deviations is extreme.
And all it's asking for is the probability.
Yeah, that it could be either one.
Right. Okay. 0.04.
So that's why we. Yeah, 0.046.
Okay.
I'm not sure it's asking for the below. The way it says, find the probability that a random sample of passengers will have a weight that is as extreme or more extreme, either above or below the mean.
You think it'll be just above?
It says either above or below the mean.
Yeah, I just saw that in parentheses there. Okay. No, yeah, okay.
Yeah.
And was observed in this. Okay.
But it doesn't really matter what the sample is. All we're finding is the probability of what's extreme.
Right.
Yep.
I mean, we could, it could be 185, it could be 177, and it doesn't matter.
Yeah.
I'm okay with going with the one.
Okay.
That answer.
Which of the following will have a smaller standard deviation? If 9 observations are randomly drawn from a population, the distribution of the individual observations, X, distribution of the sample index, this cannot be determined.
The distribution of the second.
That'd be the sample means, right?
Yeah.
That's going to be tighter.
Yep. Because all the other ones are just random data or not even really an answer.
Right.
Okay. I'll do 6. Which of the following results implies that the spread?
Yeah, the means are all going to be like.
Oh, go ahead.
No, you can go.
Okay. Let's see. Which of the following results implies that the spread in X decreases as the sample size increases? The normal distribution, the 68, 95, 99.7 rule, central limit theorem, or the law of large numbers?
I think it's the law of large numbers.
Yeah, I was thinking the same thing because the central limit theorem is more about the shape, right?
Yeah.
Yep.
And normal distribution.
Okay.
Yeah.
I could read the next one, I guess.
Okay.
Scores on the quantitative portion of the GRE are approximately normally distributed with the mean equals 50.8 and standard deviation equals 8.8. Use this information to answer questions 7 to 10. 1. Source ETS GRE. Oh, okay. I don't know. Okay. So 7. Diane earned a score of 160 on the quantitative portion of the GRE. What is the z-score corresponding to Diane's score? Round your answer to 3 decimal places.
What's the sample size?
The older one.
Actually, it's just individual. That'd be her individual EZ score.
Yeah, go to the original standard deviation question. For this thing.
Yeah, that's 2 lessons ago.
Oh.
Yeah.
The 2.5 is the X. Oh, wait. No, her is 160.
Yeah. You got 160, so that's going to be your X. The mean is going to be the 150.8. The standard deviation is
8.8.
1.045.
1.045.
Okay.
And that is found, I just want to kind of do this. So you take the number minus the mean divided by the square root of the standard deviation.
Right.
The square root of the standard deviation is like 2.2 or something. I don't know exactly, but it'll be small number divided by the smaller number. About 2 or 4 maybe. Okay. What is the probability that a random
Hold on, just
selected
1 second.
student will score?
Sorry, guys. Go ahead.
Okay. Number 8. What is the probability that a random selected student will score above 160 on the quantitative portion of the GRE? We can plug in our z-score now to the applet.
And we get 0.148.
0.148.
Okay.
And that's just done by taking the answer from the question we had before, the z-score, for 160, plugging it into the applet, and only selecting the upper portion.
Yep. Okay. Let's see, I'll do 9. A random sample of 5 students was selected to take the GRE. Their scores are 160, 175, 163, 149, and 153. What is the z-score corresponding to the sample mean of these student scores? Oh, so we need to calculate the mean first.
So you got average result.
Okay. What are the scores?
So you got average of 160, 175, or 100, yeah, 175. 163, 149.
So 160.
Yeah.
Yeah, I have a mean of 160.
Yep. And so z-score is going to be the same as number 7.
But now we have a sample size of 5.
What is the problem? Or is everyone okay with that?
Wait, sorry, what did you have? I was looking at something else.
So the mean or the average of all of these samples,
Yep, is 160.
and we already did that up here. They want to know the z-score of that. Since we already did that, we'll just say the same answer for.
Yeah, but it's not the same answer because we have a group of 5 now. So we
There's a population or a
needed to change the population size. We need to use it at.
They're saying the x value is 160.
Yep, and the standard or the mean is 150.8.
Deviation is still 8.8. Now we have a sample of 5.
So do we,
Standard deviation of these.
So-
going to be
I got
So
2.33.
that z-score will be 2.338.
Okay, good. That's what I had.
Good catch.
I can do 10.
Okay.
What is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem? Okay.
greater than 160.
Yeah.
Yeah, so we just need to stick it in the applet, right?
Yeah.
Yeah, so it's 5 students again, randomly selected.
So the z-score is still the same. We just need to stick it in the. Yeah, you got it. Is that 3 zeros and a 7?
It's 0.0019.
More decimal places, so it'll be 0.0097.
Oh, 9.7. Sorry, I thought that was a 0. So it's 0.0097.
Yeah.
Thanks, guys.
All right.
Suppose that the mean GPA of, sorry, do you want to do that?
Go for it, man.
No, you got next one.
All right.
Suppose the mean GPA of BYUI students is 3.5, standard deviation of 0.7. It is well known that the distribution is left skewed. A random sample of 81 students will be drawn. Alright, so use this information to answer problems 11 through 15. What is the shape of the sampling distribution of random X, which represents 81 students? That would be approximately normal.
Yeah.
Is everyone okay with that?
Yeah.
Okay.
Who's got 12?
That was
Okay, cool.
What is the mean of the distribution of the sample means, sampling distribution, for all possible samples of size 81 that could be drawn from the parent population? Round your answer to one decimal
3.5.
place.
Uh-huh. Because the mean doesn't change.
Oh yeah.
3.5, is that what we have?
Yeah.
Okay.
The mean doesn't change. If the
Oh.
population is large enough.
Yeah.
Okay.
Alright.
All right. Is it back to me?
I got this one.
Oh, okay.
Okay, 13. What is the standard deviation of the sampling distribution of a random variable x? The mean of the 81 students who are selected.
So standard deviation divided by the square root of 81. So 0.7 divided by the square root of 81 should be 0.078.
Can you say that one more time?
So they want
I just got a different number. So we're doing the standard deviation is
the
0.7.
standard deviation is 0.7.
Yep. And the
And
sample
then you
size.
divide that by the square root of 81.
Oh, sorry, I hadn't. I hadn't hit enter.
Oh, says it's 81.
So you have 0.078. All right.
0.078. What is the probability that the mean GPA for 81 randomly selected students will be less than 3.3?
I was hoping this would be like the 68 and 95, 99 roll, but it's not.
No, it's negative 2.571. Put that up here. Negative 2.571. That is what I said, right? So the x value we're looking for is what's the probability that it's less than 3.3?
Yeah.
And then the mean is 3.5. Standard deviation is 0.7. Sample size 81. So we get the new standard deviation in, and then we get this guy, negative 2.571. Negative 2.571. Okay, good. And then and we get 0.005.
3 decimals. Yeah. So 0.5%.
Half a percent.
0.0051, correct?
Yep.
Okay.
Well, I mean, you're only using 3 decimals though.
Yeah, so 0.005.
Oh, thank you.
So the next one is just, if it's greater than, we can just take this answer and subtract it from 100.
Point.
So 0.9, my brain is fried, 95.
Yeah, I think so. Yeah.
So it's 0.995.
Or we can be lazy and plug it in. Anyways, there we go. 0.995. Yeah.
Yeah.
The last question.
Yep.
All right. Is that it?
Yep. 100%.
Ruby.
What?
Woo.
Nice. All right.
Okay.
Thanks, guys.
Awesome.
Yeah.
It worked. Oh, my Google thing died out.
Anything else?
Oh. Yeah. No, just send the group to me.
Will do.
Yeah, my. Where is that? Tab.
Okay.
Okay, you
Well,
guys have a good night.
have a good night.
All right.
Yeah.
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 Okay, bye.